What I'm going to teach you today is a really complex topic, and so you are going to want to take notes and probably review parts of the video several times. And so these are notes for doing combination circuits when you have resistors in series and parallel, and you will be doing problems like these on positive physics, and so you will, want to pay attention. So we are going to be solving circuits, and what that means is you're going to be finding the potential difference and current for each resistor. So there are steps to this, and the first step is you want to find the Req for the circuit, and you do that by combining resistors. So you can only combine resistors that have the same current going through them or the same potential difference across them. So when I look at A, B, and C, or resistors A, B, and C, um, one of them is in parallel with the source, and these two are in series with the source. And so which resistors have the same current? So the resistors that have the same current are A and B. They are in a series, and so whatever electrons start here at A, they have to go through B. So those are in series, so I can combine them, and that is where I would start. Now, I will also tell you that it saves time in the long run if you redraw your circuits each time you find an equivalent resistance. And so the next step on this would be, I would draw A and B as a single circuit, and I'm going to call this RAB, and then I will have RC over here. Now, RAB, because they are in series, that is just equal to RA plus RB. So that would be step one. I'm actually going to move this over. Okay, I'm still not at REQ for this circuit because I have two circuits that are in parallel. These have the same potential difference across them, so I can combine them. And if you want to know how does that happen, the coloring that you did in Know Your Potential is really helpful. So I know that all of this is high, and I know that I'm going to do it in green, all of this is low. I can see across each resistor, I have pink to green, and that tells me I have the exact same potential. If you are ever unclear about whether something has the same potential, just go back to your coloring. So this was number one for combining. Number two for combining, I'm going to this is going to be my REQ. So REQ, I was combining RAB plus RC in parallel. So 1 over REQ is equal to 1 over RAB plus 1 over RC. So that's how I would work with that circuit. All right, next circuit. Which resistors do I combine first? And the resistors I'm going to combine first are RA and RB because they have the same potential. How do I know? Again, we're going to use our coloring trick. So this is all red. I know this is all blue. And so in between, I have yellow, orange, or green. It doesn't matter what. And so I can see my potential across A is red to yellow, and my potential across B is red to yellow. So they have the same potential. So my first circuit that I'm going to draw is going to be combining RAB. So that's going to be RAB, and then I'm going to have RC. And RAB, I have to use A and B are in parallel with each other. So 1 over RAB is equal to 1 over RA plus 1 over RB. So that would be my first circuit. And then the second circuit I would find to get REQ, RAB, and RC are in series. And so I'm going to have my REQ, and REQ is going to be equal to RAB plus RC. And now, just to make sure that we are all on the same page, this RAB is the same as that RAB. So, all right. Third one, it's a more complex one. So, which resistors can I combine? And hopefully you saw that A and C are in series with each other, so I can combine them. So A and C are in series with each other. But I also note that B and D are in series with each other. So I'm going to do like 2 steps in one. So I can convert this into, it's my first step. I'm going to have one resistor that's RAC. And then I'm going to have another resistor that is RBD, where RAC is equal to RA plus RC, and then RBD is equal to RB plus RD. Now, the thing I want to emphasize is these are mathematical equivalences. In my circuit, I still have 4 resistors, but I'm using these mathematical rules in order to figure out what is the current through each resistor. Okay. All right, so now I have 2 resistors in parallel. They have, I can combine them because they have the same potential across them. Again, so I've got red is on that side, I've got blue on this side. Each resistor, I'm going red to blue. And so I know they have the same potential. Anything that has the same potential, I can combine. So I've got 2. It's my second step. I'm going to make this with 1 equivalent resistance. And this is going to be, because they're in parallel, 1 over REQ is equal to 1 over RAC plus 1 over RAD. So we're actually going to solve a couple of problems, which I'm sure probably gives you a sigh of relief because a lot of letters are sometimes hard to work with. And so I've started by looking at the first circuit. And as I said, I want to do my equivalent resistance or find my equivalent resistance. So first I'm going to combine the 10 and the 20 ohm resistor. So this is going to be my first circuit. Still going to have 20 volts. 10 plus 20 is going to give me a 30 ohm resistor. And what I usually do, I usually number, and so I'm going to say R12 is equal to that. I'm going to just put numbers on so you know. So 1, 2, 3. So R12 is equal to 30 ohms. And then I still have my 5 ohm resistor. All right, so that was step 1. And then step 2, I've got parallel resistors in parallel. So I'm going to combine them using the parallel resistance rule. First, I'm going to redraw my circuit. So this is going to be 20 volts. And again, I usually use numbers, so I'm going to call this R123. This is going to be equal to, so 1 over R123 is going to be 1 over 30 plus 1 over 5. Now, this is 1 over the resistance. I need to take the inverse in order to find the actual resistance. So the way that I would put this into my calculator is I would say that R123 is equal to, I'm going to do a parentheses for this one. I'm going to do 30. I'm going to do the inverse button and then plus 5, inverse button, close the parentheses, and then do the inverse button again. And that should give me the correct number. So, sorry, I did not calculate this ahead of time. Oh, I'm already doing it wrong. Oh my gosh, I'm just like, oh, I'm still doing it wrong. I hate allergy season. All right, I get 4.3 ohms. So I'm going to do that one more time, and I highly recommend that you calculate this so that you know that you can calculate these correctly. All right, I did it twice and I got the same answer both times. So that is my equivalent resistance. I'm going to do example 2. This is my more complex one. And again, I redraw my circuits. You'll see why in a moment, why I redraw my circuits. It saves time in the long run. So I know that this is 12 volts, and I turned this into 2. I'm going to number again. So 1, 2, 3, 4. I turned this into 2 parallel resistors. So I'm just going to use pink. R1, 2, these are in series, so I'm adding them together. 1 ohm plus 3 ohms is 4 ohms. And then I've got R3, 4. 4 ohms plus 2 ohms is 6 ohms. All right, now I've got 2 parallel resistors. So I'm going to draw my second one. So this is going to be R1, 2, 3, 4. And as before, this is resistors in parallel. So I know that 1 over R 1, 2, 3, 4 is equal to 1 over R 1, 2 plus 1 over R 3, 4. So I'm not going to write it out again, but basically I'm going to have 4 inverse plus 6 inverse. I'm going to go equal and then inverse the result. And so that gives me 2.4 ohms. And so that is my equivalent resistance. Now, step number 2. Once you have that, you find your current that's coming from the source. And so we're going to do this for each of these. So I'm just going to copy that down here. And so I know that I circuit is equal to V over R. So that is 20 volts over 4.3 ohms. And so that gives me a current. I is equal to 4.65 ohms. I'm going to do step 3 for this circuit. Step 3, you're going to find I and delta V for each resistor. So I'm going to go back up, copy the circuit. I'm actually going to copy, I'm going to start with this circuit. Okay, so paste. All right, so I know that for resistor 3, so this is 3, I know that we're just going to call it I3 is equal to potential 3 over R3. And so that is 5 ohms. No, it's 20 volts. Sorry. That would be bad if I did this wrong. 20 volts over 5 ohms. And so that is equal to 4 amps. Ooh, I see a problem. Nope, we're good. Okay. And so that means I12, I can either do it by Kirchhoff's law or I can calculate it. V12 over R12. So I've got 20 volts over 30 ohms, and that gives me 0.66 amps. And so, all right, so we're good with that. So now I'm going to go back to my total circuit, and not sure what the 2 is from. So we just kind of put everything in. So I know that this is equal to R. I know that I is equal to 4 amps, and delta V is equal to 20 volts. Now I need to do each of the individual resistors. So I know that the current through here, I is equal to 0.66 amps. And so delta V1 is going to be 0.66 amps, which is the current. So that's I1. And then times 10 ohms. This is R1. And so that gives me 6.6 volts. And then I2, I can either find from the loop law, I'll show that. So I know that my delta V 1, 2 is equal to 20 volts. And so that's going to be delta V1 plus delta V2. And so delta V2 is going to be 20 volts minus 6.6 volts. So that is, I can find it using Kirchhoff's loop law. So this is 13.4 volts, or I can just calculate it the way I did before. Delta V2 is equal to I2 R2, and so that is 0.66 amps times 20 ohms. And that gives me, when I calculated it, it's 13.2. We were rounding, so a few like decimal places off is not going to be a problem. So I would do the other one, but this video is already stunningly long, and so you can watch Jack's video for help as well.